Hello guys, my name is Diego Pacheco and this will be another Java video. Today we're gonna do some refactoring exercise together. The idea of this video is refactoring the optional, so how we can increase code clarity and also deal with null in a better way, alright? So let's get started. So here we're gonna do some coding, right? So let's say we wanna code some abstraction to allow us to print with different options, all right? So let's say if I want to print, right, I just go here and I print. So like this is my message, all right? So if I do this in Java, this works, right? Yeah, we can print a message here, okay? So to capture this, we're probably gonna start and create some abstraction, all right? So we're gonna create some interface. So let's say we will call this a print, all right? And let's define what is a print, all right? So we can say it's public void print, and then you can have a string, which is the message, right? We want to print. Let me change this to interface, right? Great. We have interface that defines a print method which returns void and print. Now let's create a very dummy and very simple implementation. So we're gonna call it simple printer. So simple printer, right, will implement print, and then we will need to have a print method here, right? So we'll just print the message on the console and that's it. So on our main application, we can refactor our code, right? And we can get the interface here, and then we can instantiate our printer. We just have one flavor of printer, and then we can basically print, all right? And this should work as well. Great, is working. So now let's say we have more flavors of printer, right? So we might have, let's say, a uppercase or lowercase printer, right? So let's do this refactoring. So I'm gonna remove my printer. So actually this code will not work anymore. And what I'm gonna do is create two new implementations, right? So I'm gonna call uppercase printer. So this guy pretty much will implement print, and then I'm gonna have a print method here. Print. All right. So what I'm gonna do, I'm gonna just print the message to uppercase. Okay. Great. And now I'm gonna create a lowercase one class lowercase printer. This guy will implement print, and then you go here and say that we want to print. Okay, so I will just print, and now the message will be to lowercase. Okay, great. I have two printers, but now our code needs to switch from one printer to another, right? So basically, we can get the interface now, print P, and I need to choose if I'm using the uppercase or lowercase, right? So let's just use the uppercase for now. And then let me try to print uppercase. This is upper. All right, if I run this code, you will see it works, right? But now I have some problems, right? So I need to pick between different printers. So probably I could have some kind of a builder to help me here to figure that out, right? So let's say create a builder. So let's call it printer builder, right? And the idea is I'm gonna return a print, all right? And we're gonna have a build method, and you're gonna pass me a name, all right? And then what we're gonna do here, if name is equals to, let's say, up, All right, that's the uppercase. Then we return new uppercase printer, or otherwise else we return new lowercase printer. Okay, right, and then we go on our main. We can print main class here, and we can change our code a little bit. All right, so what we can do here is say print b, then we can say print builder dot build, and then I want upper, right? And then I can run this code. Yeah, it works. But now I kind of have like 1, 2, 3, 4 classes, counting the interface, and the main will be actually 5, right? So 1, 2, 3, 4, 5. You might say, okay, but let's write some tests here, right? So as we continue refactoring, things works, okay? So let's try to do that, all right? So if I go to my test package, so let's try to test the lowercase, right? So let me say here we do, let me open here. Okay, so we see both. So we're gonna create a class, and this will be say lowercase printer test. I already have JUnit 5 as my main dependency here. So if you see my POM, you're gonna see I have JUnit 5 here as dependency. All right. So for this guy, let's try to do simple testing, right? So let's say public void test lower case print. Let's start with that. Then we need to add test here, all right? And let's say print p equals new lowercase printer p dot print works, all right? And we need to do some assertion, right? So we would do assert dot assertions, actually dot assert equals. So what I want to verify if, let's say, if works, all right, this should be exactly like this, right? So I want to call the print method and want to compare both. So let's try to do this test. But as you guys can see, this code doesn't compile, and probably already figure out why, right? Because the printers are coupled, and they have coupling already, right, with system out. That's a way of print, right? What happens if I'm printing to a database, or I'm printing to a REST service, or I'm printing to a file system, or a NoSQL database, all right, or Redis cache, for instance. So basically, we already have too much coupling here. And it's funny because it's one line of code and we already coupled with IO, all right? And there's one big issue here, which is void, all right? If I'm returning void, it means I have side effects, and this code's basically very hard to test, all right? So what we should do is actually always return a string. And this way, we're gonna decouple the printing part and the formatting, right? By doing that, it's not a minor change, right? I'm not only changing the returning. Actually, it ends up changing the whole design, because if you look it through here, I'm not printing anymore. I'm doing formatting actually, which is subset of print, right? So this factor is much bigger, but let's do it anyway, right? So I'm gonna call this format. So actually, what I want to do is be able to format. So I'm gonna call it like formatter, right? And let's say I need to able to format, right? That's what I need to do. So I'm gonna go here. There's no printer anymore. We're gonna do refactor, right? And now I have a formatter. And in order to format, we need to be able to return string, right? So now we are not doing print anymore. We are decoupling format and print, and then have a formatter. But now I need to go on my lowercase, right? And I need to implement formatter. And also I need to say here is format. And there is a problem, right? I cannot return void anymore, and then I need to return message like this, right? And there's a naming problem here, so I don't have a printer anymore, right? So I have a lowercase formatter here actually now. So I'm gonna need to rename this guy here. Let's rename. Yeah, it works. Then we need to do pretty much the same thing for the uppercase, right? So there's no print anymore, so it's a formatter, and here we need to format. Here we need to return a string, and also we cannot print, so that's wrong. Let's return. Okay, but now the name as well doesn't match, right? I don't have uppercase print anymore because it's a different concept. So uppercase for matter, all right? That's better. Now we just need to rename the class. Let's rename it. Done. All right, all set. Now let's fix this main test here, right? The main code, I'm just gonna remove it from now, so we don't need to deal with it. But this test, all right, is different now. Now I need to have a formatter, which is F. Then I don't have this anymore, so this will be a new lowercase formatter. And now I can do this, right? So now I'm able to run this. And if I run this code, oh, it doesn't work, right? Because we didn't refactor our builder, right? So let's refactor. So the builder will run, we will return a formatter. So either this is gonna be an uppercase formatter, or let's call it lowercase formatter, all right? And the name also is a problem. So instead of printer, I'm gonna call formatter builder, and we will rename it here. Let's refactor. Yeah, now it's good, and it's not print anymore, it's format, right? Then we run again, and we are good to go, right? And the test pass, all right? The bar is green, all good. Okay, so now let's keep doing, right? So let's do a new test, right? What happens if I test with null, for instance, right? So what happens is if I'm trying to format something which is null, as you already probably spotted, this will not work because we have no pointer exception. If we take a look on our lowercase, all right, the issue here is not, we are not validating anything, right? And we always should validate the inputs no matter what, all right? So here, let's do some validations before we do this. Let's make this code safer, right? So one thing we can do here, so if null, you always put the constant on the left. It's a good practice. So null is equals the message, or if the message is empty, all right, in that cases, I want to return blank. Otherwise, I'm gonna do lowercase, right? So in this case, it's always safe, right? So I'm trying to format null or empty. I'm returning something for you, all right? So that's the whole code. So we will need the same thing for the uppercase, right? But let's get this line here. If we go to the uppercase formatter, right, we need to go here, and the code will be pretty much the same. The main difference is instead of lowercase, we need to go to uppercase, all right? And then we have both codes doing that. So in this case, it still will not work, all right, if we run, because now it's expecting works, all right? It's not no pointer exception anymore, but it's returning blank, all right? So for that case, the test is wrong, all right? So we need to expect for this, all right? And then we'll be good. Yeah, our test is passing. Now we can create another test. Let's say for the uppercase. So uppercase formatter test, all right? Usually we create packages in Java, but I'm gonna copy this one here. I'm doing without just for sake of simplicity here, but actually, you know, probably would have a bunch of packages here. Now let me change this to uppercase formatter, right? And this one here, and instead of a lower is upper, and here instead of a lower is upper, right? So what I expect here is works, lowercase. I'm passing lowercase, I'm expecting to get uppercase. And here I expect this to be exactly the same, all right? So let's try to run these tests to see what happens. And it works, all right. So now let's test our builder, okay? So we're gonna go here, I'm gonna create for matter builder test. Okay, so let's create our first method at test, and this will be public void. Let's try invalid type, invalid formatter. All right, let's try one that doesn't work. Let's see what happens. So I'm gonna have a formatter here, and this will be formatter builder dot build. I'm gonna pass is bubbles, right? This should not exist. And then what I want to do is, let's say string never happened, okay, all right. And I want to do is assertions dot assert equals, and then I want to say never happened cannot be equals to f dot format of okay. All right, so assert not equals. All right, and let's run this. So as you can see, it fails, right? But it fails on the test. The assertion fails, right? And you see expected not equal but was, right? So there was equals, and the reason was because if we look our builder here, all right, so we have a default implementation, and this is good and bad at the same time, right? Because so if you don't pass anything correctly wherever you put, we're gonna put it to lowercase, right? And that depends, right? Sometimes smart defaults are good because it allow you less configuration. Other times, if you want to implement specific constrained behaviors, and either this needs to be upper or lowercase, then you need to constrain that. But then we will create some problems by doing that. But let's do that. Let's get there. All right. So in this case, what we need to do is extend this if here. All right. So we need to say else if. Okay. So if it's not up, you need to be able to say down. All right. Let's say that's the word. And then if you pass down, right, then you're gonna get a lowercase. Otherwise, right, we have some options here. So let's start returning null for now. Okay, simple option, and that's how we get it. So let me remove one character here. Okay, this compiles. Okay, now in this case here, right, so if we press is bubbles, all right, this will return null, and we can rerun here, right? And then we see we got a null pointer exception, right? So, but then should we expect for null pointer exception? No. So null could be dangerous here, right? We don't actually want to deal with null, because null, could means like I did something wrong on my code, or it's returning null, so I never know the difference, right, of empty and null. That's why we should avoid using null. So one other option could be, instead of returning null, I could try raise an exception, right? So for that case, it could be new illegal argument exception, I would say, name not supported, right? So for this case, for the user will be not return is true. Sorry. So for this case, for the user will be much more explicit that we cannot work with that parameter, right? So either you pass up or down, but this one is not accepted at all, right? So here actually this is better because then we could expect the exception, right? And that will definitely make the code clear. However, exceptions are really, if you are in functional programming, not really the best way to deal with something unless this is like an error you really cannot recover from it, because an option could say, okay, so if I cannot do this, I'm gonna do lowercase anyway, right? Or I'm gonna just print without formatting, which probably is a much better default, right? So for that case, we need a better mechanism, and this mechanism is optional, right? So basically what we want to do is refactor to optional. So how can we do that, all right? Well, so let's change this code here. So instead of returning a formatter, we're gonna return an optional, right, of formatter, right? And in that case, for the optional, right, from utils, when we have a value, right, we need to say optional of, right, and then we pass the value. There is an interesting, let me finish this first, then I'm gonna show you some stuff for you guys. Okay, so let's do this. Okay, so now I'm returning an optional, right? So, but the exception is breaking the vibe here, right? Because ideally you should always return an optional, right? So I'm gonna remove this code here, and actually if it's not up or not down, what we want to do is optional dot empty, right? In this case, we have a better way to deal with it, right? And one interesting thing here is like I have of and I have of nullable, right? So if you pass something that's new, it would get me empty anyway, all right? So this option is really interesting because it's more safe, right? So of nullable, but here it could be just of because I'm instantiating a class, so it's sure unless and throw exception on the constructor, right? But then you're gonna get exception. So unless I really mess with the construction, but I won't. So in this case, you can do it just like that, right? But I like to do the nullable, so I'm gonna keep it this way anyway, so it's safer. Okay. So now what happens is for my test, right now I don't receive a formatter anymore, right? So that's different. So I need to get an optional, right, formatter, and then here, right, and then I need to do the import, and then what happens is by now I'm just gonna do this get, right, and then we're gonna be able to call format. Okay, so let's try to run this, right? As you see, there's one more error because I forget here to close. I have one parenthesis that's not needed here. Yes, this looks good. Okay, so now if we rerun this, okay, so you see there's no such element, all right? Because it's empty, right? So I cannot format empty at all, right? So just to see it works, right? Let me put up here. The test still will fail, right? But then you're gonna see a different error. Well, it passes, right? Because I'm comparing okay with that, right? And if we build, all right, is up, is uppercase, then otherwise is down, is lowercase, and then we return empty. All right, if I go back here, all right, so what happening is never happen is okay, all right, and then I'm getting the formatter, right, to get, which either will get me an error like a no such element exception or a value, right? So I get the formatter and then I format, right? And I'm saying not equals, and exactly they are not equals, right? Because one will be uppercase and another will be lowercase, all right? So that's why it doesn't work, right? But the test passed, but is wrong, right? But that's not what we want. So let me go, is bubbles here, right? I'm forcing a formatter that does not exist, right? But for that case, to validate is much simpler. The only thing I need to do is to compare if this actually should be empty. All right, so in that case I can do optional dot empty, and I just want to check if this is empty. If this is empty, is good, right? Then we can run, and you see there is an error, and the reason there is an error is because there is this get, right? And when we try to do get with a value that's new, right, that you don't have value there, you're gonna get an exception. So the get is pretty dangerous, right? So you should really avoid calling this get, because you don't know what will happen, right? So you want to do this code a bit differently, right? So one thing you can do before calling get, all right, is like this. So I want to do an if, so I want to see option F, right? And then I can do if present, right? So for this case, I'm saying that, I want to know if this is present or not, right? So if is present, right, then means I can call get. Otherwise, I cannot call get, right? So because if you look the code here, right, basically it verifies null for us, right? So that's definitely one way to deal with the whole situation, right? So there is another way to do it, right? It will be for us much simpler here, right? Is let's go here, right? And instead of calling get, let's just compare what we get, right? Like this way. Is even better, right? And you can see the test pass. And why it passed? Because we return an optional here, right? In this case, it won't be up, it won't be down, it will be empty. In that case, we can go here and it will be exactly empty, right? So that's why it passes, right? So now we can do other tests, like let's say for upper case test, and then for upper we say up. For that case, I don't expect anything empty, so I can say not equals, so this cannot be empty. All right, and let's check for the message. All right, so I can do assertions dot assert equals, since it's uppercase, right? So I can say upper, that will be my message, and this needs to be equals to F. Now I could do a get, all right? So let's do get, and then let's call format, all right? And this is the case. But what happens if there's a bug on the code, right? This will blow. So one thing you could do right now could say f dot get or else, right? In that method, or if there's a value, otherwise we'll call this, right? So one thing I could say is like pass a lambda here, right? In that case, I can say, let's return empty, like that could be like this, or we can even have a formatter that is to the type that you're looking for, right? But then let's not do this, right? And just let's run this, okay? So we run, it pass. Now let's do again here. Now we're gonna do the lowercase, right? And then okay, hold on, this is wrong. Need to put down, and then this should be down. And here I'm gonna put uppercase down. All right, this should match. Let's run this guy here. Yeah, it passed. We can run all of them. It passed. All right, great. So we have covered all the tests, right? So we have trying to put something that does not exist. We have our uppercase and lowercase, and with the optional we are in a much better place pretty much, right? Because either we get a value or we don't, right? So now we could change things a little bit, all right? So let's say we go to the main, right? And now we can play with this in a different way, right? So now let's say I'm gonna have a formatter f, and then I'm gonna call formatter builder dot build, and I'm gonna get something uppercase, right? And I wanna actually this is optional, so now either I get it or not, right? And then I can say if f dot is present, right? So if I get a formatter here which is not empty, right? I want to do the formatting. So now I want to print, right? So I want to say f dot format, f dot, I can do a get because I validated here, so we'll be good, right? And then I can say format and say this is working. Okay, otherwise it doesn't work, right? Because it's not present. But anyway, what I can do, I still can say here no format. All right, so let me change here and say no formatter available. Oops, there's a typo here. All right. Oh, let's type again. Available. Okay, good now. I can run this, right? And you're gonna see it works. Yeah, this is working. And if I pass something that like up to, there's no such a thing, you're gonna see it prints. There's no formatter available, right? So one other thing you could do, let's say you want to get rid of this if here outside, all right? Because you still need to check for formatter. You still need to check if this is empty. And if we look our tests, on the when you use the formatters directly, you don't see this problem. But when you use the builder, right, like this one here, then you start to seeing we have like similar thing, right? Because I don't know if this is gonna be empty or not. We end up not writing the test that way, right? But we could check if that's not empty. We are checking the exceptions, right? But if like is a code that's using it is more like a consumer, right? It's more like this, right? And in that case, you need to have this thing here. So how could we remove this if, right, and make it more safe, right? So one option could be we have some empty formatter as well, right? So I'm gonna call empty formatter, right? So the empty formatter, right? This guy here, we're gonna implement formatter, all right? And then we need to have format here. And what we can do, all right, is just return empty string, all right? We don't care about the parameter, just return empty string. So in our code, we will need to refactor a little bit. So instead of return empty, right, we will return optional of. I'm gonna put nullable, right, and then here will be a new empty formatter, right? In this case, you're always getting a formatter. So if I run main, right, now I don't need to worry if it's present or not, because it will always be present, right? So I make get safe, right? Um, so in this case, I can do this, right? And you're gonna see what will happen. It prints nothing, right? Because this doesn't exist. But if I do this way, then it works, all right? So if you control the API, it's, that's, I would say, is very elegant way to deal with it. If you don't control the API, probably you want to validate if it's present or not, and it's better to check with that on our side as well, all right? So you make sure, if the implementer, let's say that there was a team who made a builder and you was not there, it will, or you cannot change this code here, this in a library or something like that. You definitely want to do that in your side, all right? But now, if we go back to the tests, all right, so we have the lowercase here. Nothing should change because we are dealing with the lowercase directly. If we go back to the uppercase here, you see nothing changed because we're dealing with the uppercase directly. However, we have the builder now, right? And then as we run here, there's one test that doesn't pass. Why? Because now we don't return empty anymore, right? So what we need to do here, right, is basically change the test a little bit, right? So first of all, when I pass something that is here doesn't exist, right, like bubbles, I won't get empty, right? I'm gonna get another formatter. So I need to compare this with new empty formatter, right? Now I can get that guy for me, and it should work fine. So if I run here, oh, it doesn't pass it, right? And the reason is here I have an optional, all right? So let me go out and do get, all right? And here we go again. And then after calling get, it still doesn't work. Why? Because it's a different instance, all right? So the object is not exactly the same, although it's an empty formatter, right? But it's really not the same object, right? So we need to make this object unique. We need to fix this. And also, doing the new here is not like ideally. Ideally will be better if the API provide that for me. So let's do this refactorings, right? So we go back here to the builder, right? Actually, what you might want to do is, like, let's say a method public. It could be even a property. So we make sure it's the same object, will be even easier, right? So we do this public static final, and then I'm gonna call empty, right? And this will be new new empty formatter, right? And then this will be the type of formatter, all right? So in this way, we just have one instance, right? We don't have that problem. And also you enforce the usage of the builder, right? So for that case here of nullable, and then I'm just gonna say empty, right? Now I can go back to the test, and actually what I would check here will be formatter builder.empty, right? So whatever I call here, it needs to be the same instance, because we really don't need to be creating these classes all over and over again, right? So as you see, we fix the issue very easily by moving the responsibility to the builder, right? And we see the same behavior on optional as well, right? Because as you saw there is an empty optional built in there, right? So with that solution, all right, not only it makes easier to make comparisons about empty, but also your code, it works, and we need to do much less validations, right? So there's always these trade-offs. There's a bunch of things you can do. So let's try to wrap up and see the options here, right? So basically, you want to avoid returning nulls. If you return null, it's very hard to differentiate if it's a programming error, a logical error, or a bug, or it's just like that means empty, right? So don't use null, use optional, right? That's one thing. Sometimes it will be okay to return exception, and that really depends on the semantics and how do you want to behave. So if we go back to our builder, right, I could return exception here, but then your code probably will need to deal with that exception anyway, right? So I believe that's okay to throw an exception in the cases that you really want the program to blow. But if the user of this code will do something, right, using exceptions to control the flow might not be the best usage, right? So let's say if you go optional empty, right, it help us, right? But then it's really more code if you have your code that's doing printing, right? So if we create a empty implementation of our interfaces, which is in our case is the empty formatter, right? That's even safer because we can do our code and will definitely work, and that's expressed on the main. So before we had to do an if here to see if it's present, and now I can safely call it that. So what I'm saying is like I can call get because we build the abstractions in place to make sure get's safe, right? You might not have that always, so you might want to check before calling get, right? To check for presence, otherwise you might have issues. And finally, we fix the issue of checking for an empty formatter by having a single instance here with a static panel, so we make sure we always have the same instance. And then the tests, like we show here, they can check, right? They can rely on that empty to do comparisons, right? So that's what we did. So that's it for today, guys. I hope you guys like it. See you next time. Bye.